recording. Then we're going to share, but I'm going to have to open a new page. So I'll lecture 20 notes 02 are inverse. So I hope you can see my page, right? Thank you, Luca. And
yes, we can see it.
thank you. So did you see, Rafael? Did you see the homework on the previous page?
Yeah, I did. Thank you, sir.
Okay, you're welcome. So I have to record. I think I'm still record. Yeah, I'm recording. All right. So the derivative of inverse functions. Some functions are the few inverse functions that we want to deal are the sine inverse, cos inverse, and tan inverse. So I want to know what the derivative of this is. Sine of inverse of. I can call it x for now. Doesn't matter, or u or x. You always use x to simplify the derivative, and then when we generalize, we use u as a function, right? So actually, this means what? You know, when you have y equal to sine inverse x, it means x equal to sine y, isn't it? Say, for example, sine of 30 degrees equal to 1/2. Sine inverse of 1/2 is 30 degrees. That's what it means, you know. You go the opposite. If this was the relationship of a function, this is a relationship of f inverse. When the direction is what f inverse is. Okay? This is f. F inverse will be going backwards. That's the inverse function. It's very, very important in mathematics, the inverse functions. Okay? So when you say sine of x equal to 0.4, okay, x is simply sine inverse of 0.4. That's why we use the second function on the R calculator. Those are important. So I think I want to find the derivatives of sine inverse, cos inverse, and tan inverse. And what is the derivative of dy by dx is my question. Okay. So from here, that is a question we have. But from this, what can you say? Implicit differentiation, maybe. What can you say here? The derivative of x is 1, but the derivative of sine y is cos of y dy by dx, right? 1, the derivative of x is 1, the derivative of sine of y is cos of y times y. When we encounter y, we have to attach dy by dx. So from here, we can say dy by dx is 1 over cos y. Divide both sides by cos, you get 1 over cos y. And we know cos y, but we know also from chapter 20, we know that sine squared y plus cos squared y equal to 1. So I want to find what cos y is in terms of sine, because sine of y is already x. So sine of cos of y, cos squared of y is 1 minus sine squared of y. And then cos y is square root of 1 minus sine squared of y. But sine is x, so it is square root of 1 minus x squared. So you can go back here and place this instead of this. So therefore, dy by dx happens to be 1 over root of 1 minus x squared, where x is sine y. What is y though? The y was d by dx of what? Y was sine inverse x. The derivative of sine inverse x is 1 over root of 1 minus x squared, they say. Okay, so for with this, we got what? Sine, the derivative, we want to just summary. So the derivative, where were we? What was a last section where the formulas were up to 6. Now this is up number 7. The derivative of sine inverse of u by dx is 1 over root of 1 minus u squared, the same pattern, du by dx. Number 8, if you do the same process for the cos inverse of u, it is minus 1 over root of 1 minus u squared du by dx. For the tan is a little bit different. If you do the process, you will get for the tan inverse of u as 1 over 1 plus u squared du. There is no radical in the tan. So I'm going to include these formulas on the formula sheet. We are up to formula number 9 right now. So, but then the reasoning why we get for the sine is that you can try for the cosine at home. You can try it for the tangent. You will have to be able to derive these formulas. Okay. So the inverse of the derivative of the sine inverse is 1 over root of 1 minus the angle square. I mean, not the angle, the value square, value of u square. So the derivative of the cosine inverse is exactly like the sine, but with a negative sign. Just it looks like exactly like this, but with a negative sign. The tangent is completely different. There is no radical, and it's the sum of 1 plus u squared. These are additional formulas to the things we have done up to now. So I'm going to do examples. We should acquaint ourselves with these formulas. They are important. So examples are on section 27.3 on page 843. So number 4, well, the instruction is find the derivative. So the number 4 is r, they give us r equal to 3 sine inverse of 4 minus t squared. So we want dr by dt. dr by dt, you see this is inverse. So it has its own derivative. What is the sine inverse of u? Consider this as u, as one entity. Okay, is 1 over root of 1 minus u squared. You have to complete the cycle. The 3 has nothing to do. The derivative of that is 1 over square root of 1 minus u squared times the derivative of u. See that? So this is minus 6t over the square root of 1 minus 4 minus t squared squared. That's my answer. You can leave the inside here. You don't have to FOIL it. If you do, you get 1 minus, how do you FOIL this? 16 minus 8t squared plus t to the 4. So it would be negative 15 minus plus 8t squared minus t to the 4. You could have replaced the inside, the whole inside like that, or it's negative 60 over square root of 8t squared minus 15 minus t to the 4. You can say that. But I prefer this. Okay, next question is number 6. Y equal to sine inverse of root of 1 minus 2x. What is dy by dx? Well, what is the sine inverse formula? Sine inverse is 1 over root of 1 minus. It's the same. 1 over root of 1 minus u squared. What is u squared? Root of 1 minus 2x squared is simply 1 minus 2x. So 1 minus 2x times the derivative of u, which is bring the 1/2 up front, write the base, subtract 1 from the exponent, times negative 2. So this is on the top, these 2 and these 2 can cancel. So what I have is it's negative 1 square root of, here it is square root of 2x, and in here it is square root of 1 minus 2x. Because you can take this to the denominator. Take this to the denominator. What do? Change the exponent. Change the exponent sign so it becomes positive. So when you get 1 minus 2x to the positive half, that's the square root. Actually, the 2's cancel. This minus is taken care of. I brought it up here. So that's what it is. That is the answer. So number 10, y equal to 3 cosine inverse of x squared plus 0.5. Of course, cosine inverse has a different derivative. Dy by dx would be 3. What is the cosine inverse derivative? It's minus 1 over square root of 1 minus the angle square, x squared plus 0.5, the whole square, times the derivative of the angle, which is 2x. So minus 3 times 2x minus 6x over with a minus square root of 1 minus x squared plus 0.5, the whole square is good at. So you just follow the pattern, okay? Number 14, if y equal to 4 tan inverse of pi u to the 4. So this is your u, technically, you know, your angle. So dy by the u is 4 has nothing, and then what is the inverse tan formula? It's 1 over 1 plus u squared, isn't it? du by d times u prime. So what is the derivative? 1 over 1 plus u pi u to the 4 the whole square. That's your value of the u times the derivative of the inside, which is 4 pi u cubed. Bring the 4 up front. Pi is a number, so keep the pi. U take away 1 from the exponent. Okay, let me double check. 4, the inverse of tan has 1 over 1 plus u squared times, you complete that cycle, times the derivative of u, which is this. and then we're done. So this is, the top numbers are 16 pi u cubed over 1 plus, you can also this FOIL the exponent for this answer. And there is a product rule, number 16, application of product rule, x to the 6 cos inverse of x. dy by dx is the derivative of the first, 6x to the 5, times the second, plus the first, the derivative of the second, which is negative 1 over root of 1 minus x squared. The derivative of cos inverse is negative 1 over root of 1 minus u squared. U is x in this case. There is no, this is, it's not a function, so it's the derivative of x is 1. You don't need to attach, right? So this is 6x to the 5 cos inverse of x minus x to the 6 over square root of 1 minus x squared. I just want to mention that this inverse, when they say cos inverse of x squared, like cubed, it's wrong to say cos negative 3x or cos of x to the negative 3. It's wrong. You're thinking this is exponent. No, it is not exponent. This negative 1 is not exponent. It is actually a notation. This negative 1, but it is a notation. A notation for what? For the inverse. This is a notation, not exponent. For the inverse function. Okay, please don't make that mistake. Don't treat it as a number. No, it's not a number. It's a name. This is nothing but Arccosx. Sometimes they call it Arccosx x cubed. They use Arccosx for the inverse sometimes. Arctan, Arccosx, Arcsinx. So but the book uses inverse for negative 1. It doesn't have a value. It's not negative 1. It's not. It is the inverse of cos. So it is the inverse of cos. Inverse of cos. Not cos to the power of, or to the exponent of negative 1. Okay, please. We have to understand that. You have a question, Luca?
I have a question. Is there an application for Arccosx to the power 2 or 3? Because usually we use the Arccosx for finding the angle. So,
yes, but the application could be if it's part of a process, for example. If a part of equation, you might end up having a solution with a square with many. Like if it's part of the equation, if you are solving, for example, x to the 1/3 equal to sine inverse of x, or sine inverse of say 2 pi, then you're gonna make a part of this. You're gonna make a part of this. You know what I mean? Then you end up x equal to sine inverse of 2 pi to the power of 3. Then that's a number. That's valid. You find the sine inverse first, and then so it depends on the equation you're working with. You might encounter sine inverse to the power of anything, really. Wissam, did I answer your question? I don't know. There is I have encountered a lot of the inverse functions to the power, because you end up having to solve them, and then they retain some exponent in them. Is that okay? Okay, thank you, Wissam. Yeah, I got it. Yeah. So, okay, but the argument is many of my students, especially who are learning these inverse functions in this section, they misuse them as they treat that -1 as a number, which is not. It is just a notation. So could we do like also did we do product rule already? Yeah, we did product rule number 16. We could do quotient rule. Like number 22. So y equal to x squared plus 1 over tan inverse of x. The derivative of dy by dx is the derivative of the top, which is 2x, times the bottom, tan inverse of x. I'm using quotient rule. Use quotient rule. Minus the top times the derivative of the bottom, which is 1 over 1 plus x squared, isn't it? Your angle is x, so x squared. That is the derivative of tan inverse of x, divided by tan inverse. See, we have even tan inverse of x squared here right now. Because of the process, we end up having tan inverse squared. Yeah. So therefore, I'm going to have to simplify this because this is a problem. So this is 2x tan inverse of x minus this is what? Oh, it is actually not a problem. It's perfect. Isn't it 1? Yeah. So minus 1 over tan inverse of x, the whole square. That is it. You can't say this denominator as tan to the negative 2x. That's wrong. Right. So by coincidence, if this was not 1, then you would have had a over b, a minus b over c over d. You would have this situation. And then you know that this is ac minus b over dc. You would have applied that because there is a fraction here which is only limited to the numerator and then divided by a denominator. So you have to adjust. You have to make one fraction, not a division after division. Like a division here over division is not acceptable representation. Okay, so you got to do it like this. But in this case, they cancel each other and give me 1. So it was. It's not. I should say it's not equal to tan. No. This is not correct. That's what I say, not equal to. This is meaningless, really, unless you do tan of inverse of x squared is meaningful. This is correct. So let's do like number 26. Y equal to square root of sine inverse of x minus 1. So dy by dx, oh, this is what? Nothing but sine inverse of x minus 1 to the power of half, isn't it? So take care of the exponent first by power rule. 1/2 sine inverse of x minus 1 to the exponent of negative half, right? Times the derivative of the inside, which is 1 over 1 plus, 1 over the square root of 1 minus the angle x minus 1 squared times the derivative of the angle, which is 1 in this case. So let me repeat. Bring the half, write down the base, take away 1 from the exponent. That's n minus 1 times du by dx. What is the derivative of the base? That's sine inverse. So 1 over root of 1 minus the angle squared, not the angle, the value squared. It's no more the angle when it's inverse. The value squared times the derivative of the side, which is 1. So we're done. So I have, these are kind of 1 over there, all in the denominator, 2 sine inverse of x minus 1 square root, right? And then the square root of 1 minus x minus 1 square. You can FOIL this. You can FOIL this and then have it a reduced one, like 1 minus x squared minus 2x plus 1. So this is 1 minus 1 is 0, minus x squared plus 2x. So you could say 1 over 2 root of sine inverse of x minus 1, 2x minus x squared. You could say 2x over minus x squared. Because this 3, if you FOIL the x minus 1 square, you will get this one. So I will do one more question. That would be it on this section, number 30. Y equal to sine inverse of x minus root of 1 minus x squared. dy by dx is what? dy by dx is sine inverse of x's derivative is 1 over root of 1 minus x squared. The derivative of that is bring the 1/2, 1 minus x squared to the minus 1/2 times the derivative of this side, which is minus 2x, isn't it? So the 2 is cancelled with a 2. I have 1 over root of 1 minus x squared. And then we got plus because this minus become plus. So it is x over root of 1 minus x squared. X over, this is negative exponent. It goes down to the denominator with a positive exponent. And then fortunately, we have the same denominator. This will be LCD. The lowest common denominator is square root of 1 minus x squared. And then 1 plus x is what the answer is. That's coincidental. So this is the answer for this. So far, okay. Then we have to move on to the fourth section. If it's okay with you, what I have done. We've got good examples, so that would be good enough for this section. So I want to do some applications from textbook. So this is section 27.4. And they say applications, not. So there is nothing I could. There's nothing I could give you as a guideline. The application methods are already introduced. Application methods are what? Finding the tangent is application. Finding the normal is application. Using Newton's method is application. Newton's method to solve a problem. right? And parametric curves is application, right? Related rates is application. Graphing is application. And what? And optimization, which is maximum and minimum value of a function, which is optimization. Maximum and minimum value of a function is application. You know, linearization of is application. All these can be asked here in this trigonometric chapter. Or they give you a trigonometric equation, they might ask you find the tangent line. They say, oh, okay, well, sine of x plus sine of 3x equal to is equal to 4. Solve it using Newton's method. Well, you get sine x plus sine 3x, sine of 3x minus 4 equal to 0. This is your function f of x. Now you know how to find the trigonometric derivatives. You can do the Newton's method. Start from this point and then use x2 is equal to x1 minus f of x 1 over f prime of x1. That's the formula for Newton's method. So all the applications that we have done before with the derivative, they still come up in this section with trigonometric functions. That's all I can say. So all application topics discussed in chapter 23 and, well, not 23, 24. Can be discussed here again. Discussed to solve problems involving trig functions and their derivatives. Okay. Okay. So therefore, I will just directly take you maybe a couple examples, you know. So page examples, page 847. Just a sample example. I'm not really. So I want to do like word problems. Number 16, for example, the phase shift phi in a certain electric phase shift is for everyone, not electric only. Electric circuit with resistance R and variable capacitance. C is phi equal to tan inverse of WRC. Okay, so this is your variable. Be careful. These are constants. So what they are asking is, So find the equation for the instantaneous rate of change of phi. No big deal. It's a lot of writing, but the question is no big deal, of phi with respect to c. You know instantaneous rate means. What is that? What do you think of when they ask you instantaneous rate mean in mathematics or in calculus? Instantaneous rate of change means what? The derivative. Yes, it's the derivative. So always think like that. Our function phi is, this is a solution. Our function phi is tan inverse of, this is easy, it's a lot of writing, WRC. Don't think this is like your x, because they say variable in a certain, where the capacitance, a variable capacitance, you know. Yeah, so that's why with respect to these, they are asking you, yeah. So so instantaneous rate of change is the derivative. So d phi by dc is, what is the tangent inverse derivative? 1 plus 1 over 1 plus the value of the u squared, right? WRC squared times the derivative of the angle, which is WR. Because it's like, what is the derivative of that? If this is a number, the derivative of that is WR, right? So therefore, this is simply WR over 1 plus W squared R squared C squared. That's what the instantaneous rate formula is. Side number 17, for example. I know it is an odd number. I think I put that on your in your practice test. Okay, in studying water waves, the vertical displacement y in centimeters or in meters of a wave was determined by y equal to 0.5 sine of 2t plus 0.3 cos of 2t, where t is in seconds. Find the velocity. I think the magnitude, I say find the magnitude of velocity. The magnitude, of course, because we know it's going up and down of the velocity and acceleration for t equal to 0.4 seconds. So, okay, the velocity is dy by dt. That's vertical. This is a wave, so we are talking about vertical. There's no x component. It's vertical. So dy by dt. What's dy by dt? This is a solution, the answer. So dy by dt is, what is the derivative of that? It is 0.5 times the derivative sine is cosine of 2t times 2, right? You can multiply that with that, right? What is the derivative of that? It is plus 0.3 minus sine of t. That's the first derivative. So therefore, this is 1, which is cos of 2t, minus 0.3 sine of t. All right? That is the velocity in the y component. And that's what this is. The function is really y, because it's a wave, and they were talking about the displacement. Okay? So this is what I have. This is a formula for the derivative, the instantaneous rate of y in terms of t. Then if they want to know what is the velocity at t equal to 0.4, we just have to fix our calculator and on a radian measure, and then do what is cosine of 2 times 0.4. Okay, I got 0.696706709 minus what is 0.3 times sine of 0.4. It is 0.1168255502. So 0.696706,709 minus 0.1168255502. I got 0.575, approximately. It's 0.580 meters per second. You get almost the same. Did you follow me? Arsen, thank you. Did I miss anything with some? You had something written u square? Oh, yeah. It is for the tan inverse, right? Okay. Oh, for the when you plug the number, yes. So what is 0.4? 0.4 is in radians. You want to change it into degrees? Is that what it is? Yes. You can use that. Yes. We should be at the same number. Yeah, that's it. Okay, thank you. All right. So they also wanted acceleration. Acceleration in the y component. So ay, is the derivative of the velocity in terms of dt, or the second derivative of the second derivative of y by dt squared is what acceleration is. So what is the velocity formula? This is the velocity formula. So the derivative of that is minus sine of 2t times 2. So it's better to bring it up in front. The derivative of, I am finding the derivative of this because I have to find the derivative to find the acceleration. So the derivative of cosine is minus sine 2t times the derivative of the inside, which is 2. So that's what I have. The derivative of sine is cosine, so it's minus 0.3 cosine of t. Yeah. So to find the magnitude, I plug t equal to 0.4. So sine of 0.8 times 2 is negative 1.434712182 minus 0.3 times cosine of 0.4 is 0.276318298. Positive? No, hold on. So minus 0.3 times cosine of 0.4. It is positive, so with this minus was already there. So there will be two minuses, 1.434712182 plus 0.276318298. I got negative 1.711 meters per second squared. It's a deceleration. Of course, it's a deceleration because it's going down. It's getting slower. Does it make sense? Did you get the same?
Is it like dissipation of energy, right?
Sorry?
Dissipation of energy?
Oh,
acceleration
could be.
minus?
It could be, yes, but only they are focused on one-dimensional acceleration, which is the wave. Think of a water wave, like they are going up and down, right? But in terms of energy, yes, it's yeah, you're losing energy on going down. In then finding the one-dimensional acceleration, which is we call a negative acceleration, is a deceleration. It's slowing down somehow. It's not accelerating. It's actually decelerating. In terms of energy, it's losing some energy, which is said. I don't know if I answer your question with some or. So it's going down like that. When it's down, okay, thank you. In terms of energy, for sure, if you are thinking of energy, it's losing some energy to get smaller in number, or it's taking away 1.711 every second for the velocity to go down every second. Okay, if we have time, we do maybe one. Okay. So they are not, can I do number 22? I don't know what they are saying. And then it's velocity question. It's okay. It just parametric curves. They ask us to find the parametric curves. So machine is programmed to move on to move an etching tool. Is that etching tool? I hope I get it right. Am I saying it right? Etching tool, such that the position in centimeters. Was it in centimeters? Yeah. The position in centimeters of the tool is given by like parametric equations. X equal to 2 cos of 3t and y equal to cos of 2t, where t is in time, where t is time in seconds. So find the velocity of the tool. There is a question about Newton's method. I don't want to do it. a lot of numbers coming out in the Newton's method. But anyway, it's discussed everywhere. So could we do this? This is like magnitude and direction question. So what is dx by dt? That's Vx. Dx by dt is minus 6 sine of 3t. Do you agree with me? The derivative of x is minus sine of 3t times the derivative of 3t, which is 3, right? All right. So we can even find the value when t equal to what? Did they give us time? They didn't. Oh, they give us time. Oh, sorry. Find the velocity of the tool for t. If you have the book, you will see 4.1 seconds. So at 4.1 second, what would it be? Sine of 6 times 4.1 times 6. This I got negative 0.047. If you have different, you let me know. The Vy is dy by dt, and dy by dt, y is this, minus sine of 2t times 2. The derivative of 2t is 2, so minus 2. So at t equal to 4.1, so sine of 2 times 4.1 times 2, it is negative 1.881. So 3 decimal places. We're having the same numbers? No.
For the 3, I'm getting different number.
For Vx?
Vx.
Okay, so I'm going to do it again. Thank you. So minus 6 times sine of 3 times 4.1. You're right. It is 1 point. It's negative 1 point. Yes. Is it positive or negative? Yeah, it's positive. Positive 1.579. Okay. Thank you, Arthur and Wissam. You're right. I got 1.579. Thank you so much. So this is centimeters per second. So for the bottom one, is it okay, Arthur or Wissam? Okay, negative 2 times sine of 2 times 4.1. This is negative 1.881. That's okay. So hopefully you get right. So I got them right now. Okay, thank you. Thank you for the correction. So the velocity magnitude is the square root of Vx squared plus Vy squared as usual, which is the square root of 1.579 squared minus 1.881 squared. I got 2.456 centimeters per second. Yes, 2.456. Thank you, Arthur. All right. Now, what is the direction? Direction is theta. Where is this vector? is where is the velocity vector? It's positive and negative. So it's in the fourth quadrant. You see that? X is positive, Y is negative. It's on the fourth quadrant. So theta reference is tan inverse of the Y, which is 1.881 over the X, 1.579. So second function tan of 1.881 divided by 1.579, it is 0.872. I know what, Wissam, if you're using degrees, then you have to convert that into degrees. Then theta actually is 2 pi minus reference angle. 2 pi is like the whole circle minus this one, right? So 2 pi minus 0.872 is 5.411 radians. You don't have to write radians because obviously radians if there is no degrees. Oh. 310. Okay, what is so okay, let me double check. Times 180 divided by pi is 310 exactly. Yes. So the velocity is in the amount of 2.456 meters per second at an angle of theta equal to 5.411 rads. That's a good answer, or 310 degrees. Thank you. With this, I finish. It's already 12 o'clock. And I posted the test. It will be Thursday. The test will cover up to this point. That's it. So what did we do? Just to speak a little bit about the test. So the homework here, first let me finish. Homework. Oh, I can't write like that. Homework. Of section, a few questions I want to give you on 27.4, page 847. So number 13, minimum value. So power, phase shift, in studying water waves, find the time rate of change of horizontal component. Okay, number 21. Point on the outer edge of 38 wheel described by find the velocity of the point. Okay. Number 23. You can this number 23 is based on number 22 that we did. They want to know the acceleration. It's based on number 22. I think these are good enough. You can also try number 25. Just to show you, try number 25. Okay. All the other sections, you mean? Oh, we will do like we have a class after your test, right? We did 27.3. Oh, the homework you mean? Oh, homework. I thought I did. I wrote it down for the 27.3. Okay. don't mind. I will post homework on week 10 right now after we finish. Don't worry about it. I want to think about what I'm going to assign before.
Sir, you give us the homework in 27.2, but for 27.3 you didn't give us.
Okay, it's okay. You will find it on Blackboard, but section 27.3, page 843, numbers. You can try numbers up to, we did up to question number 30. We did up to 30. So do up to 31 odd. Actually, from the 21 up to 31 odd are very important. You do them. Even from the 15, actually. These are important, get harder. So if you cannot finish them all because too many, but this one I want you to make sure you do them. Okay? Is that okay, Rafa? Or
Yes,
Wissam?
sir. Yes.
So we've got everything then. But I will post this information on Blackboard, content on week 10 material. Okay? Have a great day. So, so there are a few sections we haven't covered. We have a class after the test, and we have also, I will also, because next week it's all about review, but I probably take the first, the Monday class. I might need to finish up my stuff. And then, are you following me? So we are, this is what I want to say. We are in week 10 right now. Week 11, Monday is review. Thursday, it's a short test, you know. The Thursday is test and plus class. You have a short class after the test. And then week 12 is Monday. I'm going to use like about 20 minutes to finish up section 27.6, which is the exponential form. It's an easy section. Monday, so 20 minutes on that, and then afterwards for these 2 hours and maybe whatever left over minutes, 2 hours, and would be review for the exam. On review the exam, I'm not going to supply anything. I'm going to ask those of you who have hard time on understanding test 1, test 2, test 3, test 4. You bring questions to class, and then I will do them for you. So you've got answers and questions of the 4 tests. For the exam review, all I expect you to do is do the test questions. What I do when I make up the exam is I lay down the 4 tests and then pick similar to those questions into the exam. So I am advising you, I'm not going to supply any document, no practice exam, nothing. I'm going to ask you to go over your tests. That will give you a best summary. And then if you have time, you go over your notes. And if you have time, you go over the practice tests, and then you go over the homework questions. It depends on how much time you have. But for my exam, if you do the tests and you know them, you will just do perfect. In other words, you will do significantly good. So what I suggest is you, as a resource, you've got test 1, test 4 with their answers. I have been posting their answers, so it will help you review for your exam. And anybody can come for the review. You can come bringing questions, and that's the purpose. The purpose is to help the students who have been struggling on the test for the review. Anybody, as a matter of fact, any student. But this is the review will help me boost their marks with the students who are struggling. Hopefully, if you're interested and if you are serious, you bring questions from which you think it will help you in the exam. Okay. So it keeps you,
Sir, I have a question. For Monday, we have only 1 hour, and so the 2 hour and 40 minutes are scheduled for the week 12, right? Including Wednesday.
so is that again? Oh,
On Monday, we have only 1 hour lecture.
yes.
So the 2 hour and 40 minutes will be between Wednesday and Monday too, right? That week.
Yes. Yes.
Okay, so
No, hold on. On week 12, we are talking about week 12
yes.
after the test.
So on the week 12, we will have is it the
A
test?
Monday. No, week 11. Next week is week 11. We do test.
Yes, week
So you
12.
will have a short class after that test.
Of course, yeah. But week 12.
Which finishes for me section 5.
Okay.
And then section 6, I need 20 minutes, a very short section
Okay.
of Monday.
Okay.
And then what's left over will be used for review.
And that will be a rest of Monday and Wednesday lecture.
Thursday lecture. We don't have class Wednesday.
Oh, sorry, Thursday, yes. I'm okay, sir. Yeah,
the Thursday 2 hours is a review. I don't do anything after you finish your test. The only 25. I mean, the section 5 and section 6 will be covered on the exam. I will cover them, and then I'll cover them in the exam. So you'll have enough time for a review. Is that clear, Wissam? Or
yes,
you want to ask something
yes,
else?
and the final date of the exam. Do we have that date yet?
Yes, it is on Thursday. It's
Yes.
9 to 12. I gave you 3 hours, but the test will be 1 hour and a half or something. I want you to have as much time as you want.
So Thursday in week 13.
Yes, in the morning.
That will be 15 of April.
I think so. Are you with George, Wissam?
Yes, sir.
George didn't post?
I maybe I missed it, but I haven't.
Well, maybe it's not yet. But I had an email stating that my exams are all set for. Like I have 2 sections of 203.
Yes, sir. And
So it will be Thursday at 9 o'clock.
Do we have the time?
9 o'clock.
9 o'clock to 12.
Yes, 3 hours.
Okay, sir. Thank you very much.
Michael, you're saying on the 22nd? Let me double check. Well, I have already set my schedule. I'll post it on Blackboard anyway. Exam schedule. Oh, so yes, it's actually the 22nd. Yes. Thank you, Michael. I can share the exam, but I will post it on Blackboard on your. Oh. Okay, finally. So, Michael, thank you so much. It's the 22nd, Wissam. You got it?
Yes, sir. I got it.
The exam is on 22nd.
Thank you, Michael. Thank you, sir.
All right. Everybody okay? Is there any other questions? Have a nice day, Michael. Thank you so much. Thank you for everybody. Have a great day. Thank you for coming to class today.
Thank you, sir. Thank you for your effort.
Nah, thank you so much. Dima, take care. Yeah, you too. Artan, have a great day. Thank you, everybody. Have a great day. Thank you, Catherine. Too. Thank you, Wissam. Thank you, everybody.